Day 135, Honors, Extra Practice Problem number 2, Simplifying Capacitor Circuits. Here I'll just have you simplify this circuit. I won't put one this complicated on a test, but let's just practice simplifying this and finding the total charge on the equivalent capacitance. So I've put this 24-volt battery in here between points A and B. Excuse me. Now you look at this circuit and you try to figure out where the series and parallel parts of this circuit are. Well, here is a series portion. This problem, we could probably do it with shortcuts. I'm not going to take any shortcuts this time, but I'm going to show you the stepwise way to do this. These three are in series. They're right in a row. Because if you're at this point and you're trying to go to this point down here, you'd have to go through all three capacitors if that were a road. Anyway, combining in series, it's just the 1 over rule, the reciprocal rule. That is 1 over 2 microfarads plus 1 over 6 microfarads plus 1 over 3 microfarads equals 1 over the total equivalent capacitance for those three. That comes out to be, believe it or not, 1 microfarad. 1 microfarad. I'm going to put 1.0, even though I'm adding a sig fig there. Eventually we'll get some decimals. And I don't want to go to 3 or 4. Well, I could go to 3 sig figs, but don't go beyond 3 sig figs. These are all 1 sig fig numbers. And it's all going to be microfarads as we go along here. But bottom line, the new diagram now will take those 3 capacitors and combine them to 1. So I'll draw that. So I've drawn the new diagram, and I've magically changed in midstream here one of the capacitors to 9 microfarads. This one right here, I'm going to make it a 9 just so it's a better illustration. So I brought the 9 down. Everything here in blue, and I've left the units off because I'm getting crowded. You can leave the units off of the diagrams, but these are all microfarads. So bottom line now, I've replaced the 3 capacitors right here with this 1 microfarad capacitor. This 9 and 3 right here are in parallel. And also this 5 and 5 are in parallel. Here's one time and I'll let you take a shortcut. These two are in parallel. These are going to combine, according to the parallel rule. 5 plus 5 will give me 10. And these are in parallel. 9 plus 3 is 12. So I'll draw that double replacement. Alright, so I've replaced the 5 and the 5 with a 10 microfarads, and the 9 and the 3 with 12, because it's just simple addition when they're in parallel. Now I have these two that are in series. Okay, you can't include the 10 with the 12 and the 6. The 10 is over there by itself. It's not part of that yet. If this guy in the middle here weren't here, if this 1 microfarad was completely gone, then the 10, 12, and 6 would be in series. They'd be on one pathway. That's only if this was completely gone right here, completely erased, and there was nothing in the center of this diagram. So that's a good example. But because this is here, I cannot include this 10 with these two in series. These two are clearly in series. If I'm going from here to here, that's one pathway going through those two capacitors in a series. So I'm going to use the rule 1 over 12 plus 1 over 6 equals 1 over the replacement. And that comes out to be 4 microfarads for the 12 and the 6 combined. And I'll redraw that diagram now. So here's my new diagram, replacing the 12 and 6 with its equivalents of 4. Now the 4 and the 1 are in parallel. They're two different pathways to get from this point right here back to the battery. That's one pathway, that's the other pathway. So the 4 and 1 are in parallel with each other. 4 plus 1 is 5. I'll draw that. Okay, so I've replaced the 4 and the 1 with a 5. Alright, now the last step. These two are in series. Even if the 5 would have been down here, that's still series. It's just one pathway around a single loop. If these were roads, I would go this way, and then this way, and then this way, and then that way. There's no forks in the road, no multiple paths. These are in series. So it's going to be 1 over 10 plus 1 over 5 equals 1 over x, or 1 over c total. So my final combination of using the reciprocal rule, 1 over 10 plus 1 over 5 equals 1 over c total, the replacement capacitor for a 10 and 5 is 3.3 microfarads. So I've put the units back in here. So that's my final goal here, is get down to 1 capacitor, which I did. And given the 24-volt battery at the beginning, now I could figure out the charge stored by using C equals Q over V. Or I could figure out the energy stored using 1/2, the energy stored equals 1/2 QV, or 1/2 CV squared. So there we have it. I won't make you figure out all the charges on all the capacitors in this diagram, because that, you can see, takes a while. But this gives you an idea, once again, of how to look for parallel and series portions of a network of capacitors that's a little bit more involved, as this one was.